Okay, we are going to look at 10.1. So 10.1 has to do with radicals. We are going to look at some terminology so that we can do this. So our terminology is this. This symbol is called a radical symbol or a square root symbol. We say it as the square root of 9. And 9, or the number underneath, is called the radicand. In this case, 9 is a perfect square. 9 is always a perfect square, but I'm just saying this example is a perfect square. And remember, we've got that chart where our perfect squares, underneath them is that undone. And we know that all positive radicals have two roots. One is 9. So if I did 3 times 3, I would get 9. If I get negative 3 times negative 3, I would still get 9. And so the negative root would be the opposite of the square root of 9. So that explains that. So one thing we're going to learn is how to simplify these just a little bit. We're going to do some easy ones. That's it. So we have a rule here. A times B is equal to the square root of A times the square root of B. And when I am looking at that, I can go the other way too. The square root of A times the square root of B is equal to the square root of A times B. So if I'm looking at 4 times 25, I am going to look at this first method here. So 4 times 25, I can take the square root of 4, which is 2, the square root of 25, which is 5, multiply them together and get 10. Okay, so that's my first method. My second method is to multiply them together using the rule. 4 times 25 is 100, and the square root of 100 from our chart right here is 10. So I get the same answer no matter which method I use, and that's what we're going to do. We're going to just simplify. So one thing that we have next is 36 times 9. So if we did the first method, what would we get here? We would get 6, right? Let's see how well I can draw with my pen here. So here I would get a 6. Here I would get the square root of 9 is 3, and 6 times 3 is 18. Okay. All right. This method, if I did the 36 times 9, I would get 324. Now I want you to enter that into your calculator. The square root symbol, enter the number 324, enter the number equals. If you are doing this on your calculator, you are going to have to turn your calculator sideways, hit 324, and then you're looking for the little one that has the 2 in this section. So it's the square root. It's right underneath the x squared button, above the sign button, S-I-N. And then you hit that and you get 18. So enter the 324 first on your phone and then hit the symbol. Okay? All right, let's try another example. 50. So if we were going to do 50, what two numbers, preferably on this perfect square chart, what would be one of the numbers that could be a perfect square? So 50 can be divided by 49, no. 36, no. See, I started like below the number 50, so 64 is too high, okay? 25, can I divide 50 by 25? I sure can. I'm going to get 25 times 2. So if we go back to that problem, I'm going to get 25 times 2, and then I can take the square root of 25, which is 5, and the square root of 2 just stays inside. So this is what's called standard radical form. And we want to take the largest perfect square out of our 50, okay? So that is one way to do it, is find that perfect square using the chart. It's probably the fastest way, and then go from there. The second method, which I think I have on the next screen, is to do a factor tree. And so anytime we find standard radical form, we're going to have a number outside and then whatever's left inside. Okay? So in this case, I've got 2 and I've got 25. And here you're talking about shoes. So if I am looking at this problem, 25 is the same thing as 5 times 5, right? So anytime you have a pair of numbers, just like if you have a pair of shoes on your feet, it can go outside of the radical symbol. We kind of call that the house, okay? So if you've got a pair of shoes on, you can take, if you have 2 shoes on, you can take your 1 pair of shoes out of the house. So that's why the 5 is on the outside, and the square root of 2, the 2 down here, doesn't have a pair. It doesn't have a friend, so it has to stay inside, okay? We're not going to do a ton of this. I just want you to be familiar with it. So, next problem, 45. If I were going to do 45, both methods, doesn't matter which method you use, but try and do both of them here in the notes. Give those a try, and then pause the video and then come back. All right, let's see what we've got. Method 1 would be finding that perfect square. So it would be 9 times 5. Okay, what's the square root of 9? 3 times the square root of 5. Okay, the 5 can't come out because it doesn't have a pair. Okay, so now the next method is to do the factor tree. I still have 5 times 9, but this 9 can be broken into 3 times 3, right? Since this is a pair of numbers, it can come out, so then I have 3 times the square root of 5. Okay? I would like you to try 200, the square root of 12, and see if you get these answers. And then we're going to skip the square root of 162. So just the square root of 200 and the square root of 12. Make sure you get these answers and have work to prove it. Okay? And then, like I said, we're going to skip 162 and we're going to talk about numbers 8 and 9. So 8 and 9 are applying that rule again. So if I was going to multiply these, there's an imaginary 1 in front, and I'm going to get 1 times the square root of 6, because that's what 3 times 2 is. Okay? Now, number 9, I need to multiply my 2 times my 4, which is 8. And then I'm going to multiply the inside, the 3 times the 5. So if I rewrite it, I got my 2 times my 4, my square root of 3 times my square root of 5. There's no pair here. These are numbers that are the smallest they can go. So I'm going to get 8 times the square root of 15. Okay? That, my friends, concludes our notes. And I would like you to try your worksheet.